Hello everyone. I'm glad to be with you today. First, let me briefly introduce myself. My name is Sajida Mhammedi and I am a PhD student at National School of Applied Science, Khouribga. And I'm delighted to be with you today to talk about Ontology for Intelligent Big Data System. My talk will be divided into 4 parts. I'll start with introduction and motivation, then we will look at the relation between big data and knowledge. Next, we will introduce the main objective of our topic. Finally, we give conclusion and future work. In many domains, the number of data sources and the amount of available data are increasing continuously. Data volumes reach the threshold of petabytes and become difficult to cope with using traditional data management system. This phenomenon is called big data. The term big data refers to a terminology widely used nowadays to designate very big amounts of data with high speed generation and wide variety of formats. Big data may be defined as the amount of data just beyond the technology's capability to store, manage, process, and efficiently. Big data can be characterized along 3 important dimensions, namely volume, variety, and velocity, known as 3 V's, as well as other dimensions of big data: veracity, validity, volatility, value, etc. This leads us to the question, how big is big data? As the examples show in front of you, there is 20-hour video uploaded to YouTube every minute, 2.9 million number of emails sent every second, etc. Big data has fueled rapid advance in the field of artificial intelligence. This is in the first place because of the availability of extremely large volume of datasets from heterogeneous sources, as well as the exponential growth in processing power due to the distributed computing. Hence, it is extremely difficult to extract value from large data volume if there is no standardization or a unified language for interpreting data into information and converting information into knowledge. Since big data remain meaningless without semantics, and in order to get a good comprehension of big data, the idea of using semantics for data integration has become increasingly crucial. Therefore, we raise the question about how big data and semantic are related to each other, and how semantic may help significantly impact the quality of machine understanding results. Let us suppose that the manager of 2 big organizations deploying big data architecture want to merge their activities and tend toward operating centrally. Data integration and interoperability will be their main focuses, since the 2 organizations may have different data management techniques. Before the merge, and the data exchange involved are enormous. At this point, ontology were allows proposed as a solution to the interoperability and the data integration problems. As we all know, there is a fundamental difference between people and computer when it comes to dealing with information. For a computer, information is available in the form of strings, whereas for humans, the information is available in the form of things. Let's understand the difference between strings and things. When we add metadata to a string, it becomes a thing. Metadata is data about data, the string in this case, or a contextual information about data. The idea is to convert the data into knowledge. In the quest to derive knowledge from data and information, ontologies play a major role in standardization the wide view by precisely defined terms that can be communicated between people and software applications. They create a shared understanding of objects and their relationship within and across domain. Typically, there are schematic, structure, and semantic difference, and hence conflict arise between knowledge representation. Well-defined and ground ontology bridge the gap between the representation. For all this reason, ontology aims to allow the representation of knowledge in order to exploit it by machines, and in the artificial intelligence field, ontology refers to the combination of data in a way that user can get a standard view. Ontology offers a solution for the heterogeneity issue and guarantee interoperability interoperability between applications exploiting the big data environment. It makes the data readable and comprehensive, and allows sharing and exchanging data between individuals, systems, and organizations without any practical effort. As a conclusion, I'd like to recap the main points of our presentation today. So, using semantics for data integration has become increasingly crucial. Ontologies aim to allow the representation of knowledge in order to exploit it by machine. Our purpose is to build a smart system for big data integration by the introducing of a knowledge layer in the big data system in order to offer the possibility of processing and exploiting the manipulated information in order for us to evolve current computational system into a more intelligent system. Thank you for your listening.